Here we are, question number 1 of your last FRQ test. Okay, we look at this problem and it's an area and volume problem. You are going to nail this. So we're given these functions here. We know that we have y equals 4 times the natural log of 3 minus x. I'm going to label my graph accordingly so I don't get confused. And then we've got up here at 6, y equals 6. And x equals 2. Okay, now everything's clearly labeled. So part A says find the area of R. Well, we know that we find the area, you take an integral, you're going to go upper minus lower in respect to x. And I know it's in respect to x because if I were to draw my representative rectangle in R, we can see that the width here is in respect to x. So now we just plug in. So the we're going to go in respect to x. So we're going to go 0, 2, and then we're going to go upper minus lower. So the upper is 6. The lower function is 4, natural log 3 minus x. And this is so then you just punch this into your calculator because it's a calculator question. And remember, when you get your answer, round it to 3 decimal places, always. So either 6.186 or 6.817. Sorry, I think I mixed up my digits there. So if you look here at the rubric then, notice you get 1 point for showing your work and 1 point for the correct answer. Okay? Now look here. Wow, a bonus. They just give you a bonus of 1 point if you used the correct limits in either A, B, or C. So since we used 0 and 2 correctly, we get another point. So now we have 3 points for a very simple problem that all of you could get. So now let's look at B. So in B, we're asked to find the volume of the solid generated about the horizontal line, y equals 8. I really encourage you to draw this so that you don't make mistakes. So y equals 8 is about here. And I'm going to take this solid here, and I'm going to revolve it around y equals 8. So we identify that as the washer method because it's not connected. And notice it's dx again. So the washer method is you're always going to go the big R squared minus the little r squared. And this is again in respect to x. So we're going to go 0 and 2, and then it's pi times that. Why is it pi times that? Because basically you can see what we're doing. Well, you probably can't see because I draw so bad. But we're taking this slice here and we're revolving it, creating a circle, a slice. Okay? So it's pi r squared. Now, what is the big R squared? So we look at the diagram, and the big R squared is the total length from the axis of, whoa, static. My hair is in the mic. Okay. So big, whoa, stop. Okay. Big R squared is going to be upper minus lower. So it's going to be 8 minus 4 natural log of 3 minus x. I hope I'm not driving you audio people crazy. That whole thing squared. And then the small square is just this section in here. So then it's going to be 6 minus, oh, wait, no. Oh, boy. See, the audio just threw me. So the small section is this section right in here. That's the part we're taking out because we don't want to include that in the volume. So that's the small r. So it's 8 minus 6 squared, and it's all in respect to x. Now, again, put this in your calculator and round to 3 decimal places. So we get 168.179 or 0.180. Now, notice this. You get 2 points for the integrand and then 1 point for the answer. Now, the last part is asking for us to do probably cross sections. Yep, cross sections, all right. Let me clean this up here. And what we need to do is we need to build squares. So I'm going to build squares in this region. Like my diagram? I knew you would. Okay, so squares, we know that squares are just the length, right? Squared. So to find the area of a square, you take one side, the length, and square it. Now this is going to be dx. So again, we're going to be going from 0 to 2. Now what is the length of the region R? Well, again, it's always upper minus lower if it's dx. So I'm going to go 6 minus 4 natural log of 3 minus x. And then that whole thing squared, squared dx. And again, I plug into the calculator, and you get either this or this answer. So that's worth 3 points. Now I want you to get 8 or 9 on this question on your AP exam. You can do it.